Good afternoon, and welcome to today's webinar. We are joined by Dr. Stanley Appeal, a leading neurologist and researcher in neurodegenerative disease at the Houston Methodist Research Institute. We're also joined by Lee Steinberg, a prominent sports agent and longtime advocate for athlete health and concussion awareness. We're also joined by Dr. Fred Grossman, President and Chief Medical Officer of Koya Therapeutics. As we begin today's discussion, I would like to focus on the issue of head trauma in sports. Lee Steinberg has seen this issue evolve over many decades, and while representing so many athletes in professional sports and advocating for player health and safety, Lee, you've been speaking publicly about concussion and brain injury for decades. What first convinced you that this was a serious issue that deserved greater attention?
There was a weekend where I was representing half the starting quarterbacks back in the 80s. And I remember Troy Aikman suffering a concussion and just laying there motionless for a period of time. And it looked like blood was coming out of his ear. And so the quarterbacks I represented kept getting hit in the head. We would go to doctors, neurologists, and ask how many is too many? When should we contemplate retirement? What are the long-term effects? And they really had no answers in the 80s because the brain is the last frontier of medical research. So I held the first player safety conference back in 1994, and we had Troy Aikman and Steve Young and Warren Moon and Drew Bledsoe and a series of players listening to neurologists. Um, a couple of years later, we had Dr. Bennett Amalu at one of these seminars, and he told us that three or more he thought was a magic number, and that triggered an exponentially higher risk of Alzheimer's, Parkinson's, premature senility, chronic traumatic encephalopathy, and depression. So I called it a ticking time bomb and undiagnosed health epidemic. And we continue to have, uh, at my Super Bowl parties, we had 2 hours of brain health last year. So we keep moving. And I now have a charitable foundation for athletic concussion that is trying to explore prevention, awareness, and cure.
So, over the years, how has this conversation around concussion changed within professional sports?
Well, it went from complete denial, where the NFL told players there was nothing to worry about, and a culture where they had television shows that were lit up the big hits, and it was almost celebrated as if there were no consequences. And that's morphed into a much more progressive uh, concussion protocol. And so today they have spotters in the press box and spotters on the sidelines to look for impaired players. And then instead of asking them how many fingers am I holding up, they have more sophisticated balance and memory techniques to diagnose the concussion. And there are a series of steps that we can do to make the sport much safer. And they're enforcing rules on not using the head and neck in tackling. So it's better, not still a major problem, but better. And the problem is the subconcussive event. So every time an offensive lineman hits a defensive lineman at the inception of a play, it produces a low level, mild brain change. So you could have an offensive lineman who played 10 years of football, who had 10,000 hits, all of which had something to do with the brain, but the aggregate of which does the same thing that getting knocked out seven to
Yeah.
10 times. And here's the problem: those athletes have never had those hits diagnosed as a concussion,
Yeah.
nor are they potentially aware of them. So they go through life not understanding that just because they got didn't get knocked out, they had no
Yeah.
brain damage.
Yeah, many people who've been associated with brain injuries, some have been diagnosed, some have not. So, what have we learned about a cumulative impact of repetitive subconcussive hits that may never be recognized as real injuries?
That they aggregate into impact on the brain that is as destructive as getting knocked out 4 or 5 times.
Mm.
And we currently don't measure them. We don't have a way of doing that. We so the player is completely unaware of the fact he's been impaired.
Now, that is very interesting, and it's something that we have to continue to discuss. And that's why I would now like to turn to the science behind what has happened with these impacts and when they occur. And Dr. Appeal, you've spent decades studying neurodegenerative diseases and the role of inflammation in the nervous system. When someone experiences repeated head trauma, what happens inside the brain, and why has inflammation become such an important focus for researchers?
Well, that has been answered in a lot of really beautiful neuropathologic studies. Unfortunately, in patients who have developed CT, chronic traumatic encephalopathy, as well as in a number who have had major concussive injuries. And what's happening under those circumstances, it's a mechanical problem of acceleration, deceleration, and it results in indeed pressure on the blood vessels where they may split. There's a little leakage, edema, blood comes in, swelling. All those are signs of inflammation. In addition, you've got activation of a variety of cells within the brain, so-called microglia, astrocytes, that are inflammatory carrying cells that can convey, unfortunately, the toxic materials that result in neuronal damage and loss of function. So we know that the key here is inflammation. You've got primary inflammation from the direct hit, and you've got secondary inflammation because the blood vessels are leaky
Mm.
and the blood elements that come into the brain aggravate the inflammatory process. So fundamentally, we're dealing with the combination of many cells contributing, and the result is that the neurons that connect are no longer connected. That is, you need the circuits for our function, and the circuits are disrupted by
Yeah.
this inflammatory process.
Well, that is a tremendous insight. Many people hear terms like CTE, Alzheimer's disease, Parkinson's disease, and ALS, and they put them all together in one group. What do we know about the relationship between head trauma and these conditions? And could repeated traumas increase vulnerability in those who may already be predisposed?
Uh, the answer is 1,000,000% yes. So here's the issue. I just saw an ALS patient newly diagnosed last week. This patient had an auto accident. This patient had a little alteration in his arm. Beforehand, he thought it was a little stiff,
Mm.
but within several days after his injury, the trauma exacerbated, accelerated a total loss of bodily function in ALS. In other words, the trauma causes neuroinflammation, and the neuroinflammation is driving the degenerative process. This occurs not only in ALS, it occurs in Parkinson's, it occurs in Alzheimer's disease, it occurs in frontotemporal dementia. All of these neurodegenerative diseases have marked inflammation driving the pathology. Now, we all understand that inflammation occurs in rheumatoid arthritis and lupus erythematosus and the
Yeah.
so-called autoimmune diseases. But inflammation is the hallmark of traumatic brain injury as well as neurodegenerative diseases.
And Dr. Bill, you've researched the immune system's role in ALS and other neurodegenerative diseases. What have those studies revealed?
Well, it's very interesting. You can look in the blood of a patient with ALS, and there are immune cells called myeloid cells, monocytes, that are activated. These cells are spitting out all sorts of inflammatory toxic materials that we call cytokines. Those cytokines interact with our T cells. And there are two kinds of T cells, good guys and bad guys. The good guys are regulatory T cells, and that's a set of cells that the Nobel Prize was just given this year for the discovery of this by Professor Shimon Sakaguchi from Japan. But there are also bad guys called T effector cells. And what's happening here is the inflammatory processes going on in these activated myeloid cells, macrophages, causes dysfunction of the protective T regs. So we end up with all the cells in the blood are showing toxicity and inflammation responses. And that's not a good thing for the neurons because then they're subject to this inflammatory toxic milieu, which is what's driving many of the diseases we're talking about, whether it's Alzheimer's, whether it's Parkinson's, whether it's ALS. All of these are being driven by this overwhelming, it's a colossal fire going on in the blood and throughout the body.
And Dr. Peel, you've explained how repeated head trauma can affect the brain and why these effects may really develop over time. While science continues to advance, it is also important to focus on prevention today. And Lee Steinberg, I know you focused on prevention and improving player safety. You have advocated for reducing unnecessary contact in practices. What changes have been most encouraging throughout the years?
So first of all, let's recall that this issue gets publicized through the NFL
Hmm.
and college football and high school football, but it's an issue in all collision sports. And so let's start, for example, with something like soccer. Having young girls head the ball,
Mm.
um, it, if you're thinking about the fact you're trying to heal the brain, then when I watch the World Cup, those people who are heading the ball are having a low level concussive event because it's contact against the brain. So, what age should we have people start with? I would advocate not having kids play tackle football, for example, until high school because the younger brain is still in formation and it takes much less to create the concussive event and it takes longer to heal from it, and kids have to go to school. They're now playing football in the Ivy League without hitting during training camp or regular season practices. All they do is model the plays, and that has been shown in some studies to reduce concussions by 40%. Uh, we know there's a genetic allele which predicts someone is more apt to be concussed. So we should be screening for that. Um, we need to teach kids from early stages how to play a sport like football without using the head and neck in blocking and tackling and teach those techniques early. And then we in sports need to penalize people that are targeting heads and are doing this kind of thing. So we need to take
Yeah.
a brand new look at all of this. Let's remember this. What makes this different from every other form of injury that a player in contact sports would say is that you may turn 40 and have aches and pains in every joint from
Yeah.
playing football or hockey.
Mhm.
And when you bend over to pick up your child, it's hard. It's another thing not to be able to recognize that child. And
Mhm.
we're talking about the brain, which is the seat of memory and character and what it means to be a sentient human being. So um, I think I love football and the values it teaches, but what I love more than that is long-term health.
Yes.
And the problem is that athletes tend to be in a state of denial, Solomon.
Mhm. Yeah.
They, at which you can testify to.
Hmm.
And they've been acculturated to believe that real men ignore pain, that real
Hmm.
men don't admit injury. So it becomes especially hard in a subjective concept like concussion. If you don't have the markers and you don't have the metrics, then you've got a client or a player who's in denial, and it becomes rough to even diagnose the concept in the first place. So, take a look at every single sport that has collision where the
Yeah.
head is involved and figure out how late in life is the earliest that someone should begin playing the sport. Um, we look at helmetry, which is not the end all solution, but there are helmets that can cushion the blow. So we look at that, and we've now found a couple processes that seem to rebuild neurotransmitters in the brain, and one of them is called RTMS, and the other one is neurofeedback.
Well, I know you have said that many injuries may occur outside the game themselves. Could be from practice, just the repeated movements, and just in preparation. So, what lessons can sports at all levels learn from newer practice models?
That that what is what the fans see is the actual play on the field. And when it comes to any activity outside playing on the field in a game, you have to evaluate whether it's absolutely necessary. And so, for example, in football, they've limited the amount of off-season hitting. So there's very little live contact. Um, Now that presents another problem because players go off to a training camp and they're in shape, but they're not in quote football shape,
Yeah.
and their body hasn't been hit, and so therefore, early in training camp, they're really apt to be susceptible to head injuries and other injuries.
We've talked about what happens inside the brain after repeated head trauma and the role of inflammation and how that connects to conditions such as ALS and other neurodegenerative diseases. Dr. Grossman, I want to turn to you next for the another part of our discussion. Coming back to the key themes of inflammation discussed today, researchers such as Dr. Appeal have identified dysfunctional regulatory T cells, as he has already mentioned, that are now playing a role in neurodegenerative diseases. ALS and other neurodegenerative diseases have affected many players in contact sports, especially in the NFL over the years. And I know that Coya Therapeutics is studying potential therapeutics for these diseases. So, what is now currently being done? What are you finding in your current studies?
So Coya Therapeutics is dedicated to finding combination therapies for neurodegenerative disorders, including ALS and FTD, frontotemporal dementia, that have inflammation as the basis for the pathology and for which there are inadequate or no treatments available. ALS is a devastating disorder with progressive deterioration of motor neurons in the brain and spinal cord, leading to paralysis, dependency on devices and caretakers to survive. And unfortunately, people on average with ALS die primarily from respiratory failure within 2 to 5 years of diagnosis. And currently, there are no adequate treatments. As you heard from Dr. Appel, regulatory T cells put the brakes on inflammation to restore functional balance. In ALS, dysfunctional regulatory T cells are reduced in number and inflammatory suppressive function. And that leads to deterioration and acceleration of neuronal damage and progression of disease. We at Koya have a potential therapy that we're studying. Koya 302 is an investigational combination of low-dose IL-2 and CTLA-4 Ig, which is designed to specifically enhance regulatory T cell number and function while reducing inflammation, resulting in restoring the immune balance. So the goal is to initiate treatment early to prevent or slow the progression, preserving motor and respiratory function, allowing for a good quality of life and prolonged survival in ALS. Koya currently has an ongoing study in ALS and will begin a study in FTD the second half of this year. We've been given fast track designation by the FDA in ALS, allowing for a closer interaction with the FDA for a more efficient and rapid development and review process. And we, of course, are looking at other combinations as potential therapies in some of the disorders mentioned today.
Well, that's really great news. And as we close out the conversation, I would like to take a step back just a little bit and look ahead at what this all means going forward. And Lee, we'll start with you. What is the most important thing athletes, parents, and even coaches should understand about repetitive head injury?
That a head injury makes the brain more susceptible to the next injury. So they used to say that if it takes that blow to do the first one, then the brain quickly is set up for that much blow to do the second one. And it adds up in aggregate. And since players tend to be in denial, it's up to parents and loved ones to intervene in the situation and make sure that they're monitoring the amount of concussions and agree that at some point prior to playing in collision sports, there will be an end to how much the brain can tolerate and what the impact is on long-term health. So it's a focus on long-term health. And it's a difficult battle with young athletes because they'll tell you, you just don't understand. I have to play. And so for the rest of us, long-term health would be the premium. And then slightly behind that would be the ability to play a pro career. And well below that, the ability to play in a given season, below that in a given game, and below that in a given play. The athlete turns that on its head, so it becomes this play is all important, and I have to be out there. Well, there's got to be people in the athletic fraternity that are counseling that young athlete that that they've got a long life after sports. Remember, aside from the occasional Tom Brady, most people who play professional sports are done in their late 30s and they have another 40, 50, 60 years to live. So that would be the cautionary note.
Yeah, for someone like myself who played professional football for 7 seasons, I do think there has to be a continuing education that we have to, that hey, our health is the long game. We're playing the long game when it comes to our health, and that it is the most important. Now, Dr. Appeal, I want to pose a question to you. Do you think insights gained from treating neurodegenerative diseases could eventually help researchers develop new approaches for addressing the long-term consequences of brain injury? And if so, why?
No question that they will help.
Yeah.
Let's talk for a moment about ALS. One of the interesting things is ALS, the disease, is also associated, and people don't realize that, with an increased incidence of other immunologic diseases. In other words, we see patients with thyroid disease and ALS. We see patients with psoriasis, rheumatoid arthritis, etc. So what this is saying is that the immune system is hyperactivated in some of the patients that subsequently develop ALS. So an understanding that this translates into inflammation and an understanding of how to suppress this inflammatory response will have a major impact going forward. What it's also telling us is we need to learn more about the genetic factors that may be driving inflammatory responses and perhaps increasing susceptibility to the likelihood that a hit on the head, and as Lee is saying, subconcussive injuries are perhaps the most important because they're the most hidden and we're regarding them least of all. But all of these put together will give us an understanding of what is the goal going forward. And the goal going forward, as Fred Grossman has described and Koya is trying to accomplish, is to suppress the inflammatory response by suppressing the bad guys with combination therapies that enhance the good guys and suppress the bad guys. And this same sort of approach can really be carried out in trying to minimize the traumatic effects of subconcussive and concussive injury in players.
And Fred, I'll allow you to address that question as well before we turn to the Q&A portion of our webinar. What are your thoughts on addressing the long-term consequences of brain injury?
Look, we're studying new ways to reduce inflammation early, which may prevent long-term consequences. We're also studying biomarkers, and of course, genetic markers are being studied. So perhaps one day that would allow us to understand those athletes that may be predisposed to neurodegenerative disorders.
Well, let's go and turn to our question and answer portion of the program. We're going to be taking some of your questions, and some are coming in right now. And this is a more general question. And Dr. Peel, maybe you can start with this one, and then I'll allow the others to chime in wherever you feel comfortable. And the question reads, how many years of play or how many hits does it take before risk becomes serious, or is there no safe threshold?
I think that's a fabulous question, and Lee has had a lot more experience in quantitating this than I do. But I will say this, if you've got dramatically enhanced susceptibility, then one hit may be sufficient to initiate a whole cascade of changes. But the likelihood is there is not that dramatic impairment in susceptibility. And in fact, it could be a smaller number of hits in certain individuals, and in other individuals, it may be an infinite number of hits, and yet there's a likelihood that long-term consequences will not follow. But I think Lee might be in much better shape to give us a quantitative approach to that question.
Lee, your thoughts?
Well, what neurologists have told me at our various brain health seminars that we hold is that 3 is a serious marker point, and that it's all subjective because it relies on how dramatic the hit was, how much damage was done, was the player unconscious, was he they do have substances now that can be, if they're used quickly enough after the hit, can prevent the swelling, and can ameliorate the swelling. But once you start to get into the range of repetitive hits, 3's just a marker. then you start to have to look at the fact that the brain may be more susceptible to a concussion than it was before. B, you're doing cumulative damage and uh, interrupting the brain flow, and uh, and you're setting yourself up for long-term consequences. Now, the truth of the matter is, there are loads of people I run into who never played pro football, but they did play high school and college football.
Yeah. Yeah.
And they say that they're having problems with memory, that they're depressed, that there are various things. They don't connect it to the fact they played football or hockey or um, any of the rest of it. But the truth of the matter is, this is a societal problem.
Yeah.
That's why I've called it a public health epidemic and a ticking time bomb, because with every blow, the brain is getting more and more impaired.
Lee, whether
So just
some, oh, go ahead, Dr. Appeal. I'm sorry.
just to add one thing that confirms exactly what Lee is saying, a
Hmm.
study was just published in individuals who played high school ball and may not, some even who didn't play high school ball, but had some repetitive hits in what they were doing with an increased incidence of brain injury that was going on. So there is no question that this is
Okay.
a long-term consequence and just doesn't start when players reach NFL caliber and time. It can start way before that, and we need to be cognizant of that in young people getting to play ball.
Yeah, very good point made. And Lee Steinberg, I want to put this question to you. Whether someone's still playing or retired years ago, is there a way to know if damage is building up before the symptoms show? Is it ever too late to protect the brain?
No, as I said, we appear to be on a track, and I'm not a doctor or medical research, but we appear to be on a track where rehabilitative uh, uh, practices, norms, uh, medicines, the rest of it, may be able to repair the brain and may be able to grow new neurons and have neural connectivity. And there are, again, some promising uh, aspects of that. I've had a couple concussions, and I went and had a procedure called RTMS, which is magnets against the brain. And they were able to measure cognitive improvement
Hmm.
after I'd had 90 sessions. And I've also done neurofeedback. And again, they have measurable results. So we are starting to see it's never too late. The problem, as I said again, is if we're talking athletics, we're talking about a group of people that are stoic, that are tough, that don't want to admit that they're vulnerable, and getting them to seek help and to do the type of diagnosis. Yes, there are diagnoses of whether or not you've had degeneration, but getting them to take it is a battle.
And Dr. Appel, just repeating the question, because part of it said, is there a way to know if damage is building up before symptoms show? Is there?
Well, I think that people are trying to develop all sorts of biomarkers in the blood that are an
Yeah.
indication that the brain is on fire and spitting out small markers that we can detect. And we're getting closer with respect to that.
Hmm.
But I also would humbly submit, maybe long term, that maybe the kind of approaches that Fred Grossman has talked about in Koya might be early interventions in some patients. So, if in fact we think that biofeedback may be meaningful, if we think that magnetic therapy may be feasible, we know the biologic consequence of enhancing protective elements in the brain, and they may be of value. Uh, maybe sooner rather than later.
Fred, is there anything you would like to add there?
Yeah, I think the beauty and the elegance of the mechanism that Dr. Appel has been studying for decades allows us to actually ask that question because we're focusing on inflammation. Now, there's a whole group of academic institutions and companies that are focusing on downstream specific targets. And that's great. They need to continue doing that, but the likelihood of success is extremely low. There are a lot of misses and very few hits. What we're focusing on, based on the work of Stan Appel and Shimon Sakaguchi, is trying to manipulate the inflammatory system in a way that maintains status quo. And as mentioned before, if we can get there early enough, we can prevent the deterioration. So I like to think of it this way. There are many groups that are swinging for the fences, going for the grand slam. We're not. We're essentially using a mechanism to affect something early on to prevent further deterioration. So we're essentially in the red zone right now, looking to develop this therapy to bring it forward for patients in need. And it's just the very beginning. And after that, we'll be moving forward in other neurodegenerative diseases as well.
And Dr. Grossman, this is a question. This next one is probably right for you because this is a family member saying that they've had a member of their family who's recently been diagnosed with ALS. And they're asking, is there anything in this research that could help them now? And how can they learn more?
So the best way to to look at this is to perhaps be a subject in one of our studies. So our current study in ALS is across the United States and Canada. We have 25 sites. And if you've been recently diagnosed with ALS and may want to participate in this study with the treatment that I described before, you can go to trials.coyatherapeutics.com. So that's trials.coyatherapeutics.com. And there we list all the sites currently participating in this ALS study. And you can directly call or have your physician call.
And Dr. Appel, this question is asking, how close are we realistically to a treatment that changes the course of these diseases rather than just managing the symptoms?
Uh, Great question, and an important one. Let me add on something to what Fred said. Since I see 5 new ALS patients a week myself, and I would say the most important fact is yes, we'd like to make sure that they get into trials such as Koya's, but get to a big center that's used to taking care of these people because we can do so much. Compared to what we did 10 years ago, patients are living longer with more quality of life, and it's based on all the things that a multidisciplinary clinic can provide. So I want to make sure that people recognize there is a way to go that's a path
Mhm.
that would be helpful. Uh, with respect to, you asked about the long-term benefit in, are we going to see things that can make a difference? Well, the
Mhm.
beautiful thing is, as Fred Grossman was saying, if we catch the patients early enough, and that's the goal of the study, then we can A, stop progression. And we found that in a very small study that prompted this larger study. And B, the most important thing is the brain is very resilient as long as you get rid
Yes.
of the bad guys,
Yeah.
get rid of the toxic, and hopefully the brain can recover. And we've seen that in other diseases. There's no reason why ALS couldn't be one of the diseases, hopefully within the near future, where we could say, hey, this is a change. This is a great change for the best.
And Dr. Appel, you talk about early warning signs and early detection. This next question asks exactly that. What are some of the early warning signs families should look for, and when is the time to see a doctor?
Well, that's a question we've all been struggling with for a long time. What is amazing is you have all the symptoms and signs, and I'll come back to that in a moment,
Yeah.
of some serious disease such as ALS. And yet you go to doctor after doctor after doctor where there's an education program. We need to get out there where the patient is not diagnosed as having a disease such as this. And the problem is we don't get to see the patient until they've had the disease for 1 to 2 years. And that delays the meaningful therapy that can make a difference. So the issue is uh, you have a foot drop, you have some difficulty, you have some problem with your hands, with your arms, you have some problem with swallowing, with chewing, with your voice, etc. The problem is there are many, many different things that could cause all of these. And that's the difficulty because when a practitioner is confronted with the myriad differential diagnoses that are probable, possible, and likely, ALS is at the bottom of the list, and that's the difficulty. So you just, after you've been to doctor after doctor, do it in a rapid succession
Yeah.
because we need you in sooner so that we can get the real therapies to help you.
Lee Steinberg, I know you're not a doctor, but you have so much experience with the neurocognitive or neurodegenerative diseases, and you've been at the forefront of helping to educate, and you've seen it across the landscape of sports. How would you answer that question in terms of identifying maybe some of the early signs and when to be active, if not proactive?
Some of the signs have been so dramatic where players can't find their way home from the training center,
Wow.
where they they lose memory and all the rest of it. One thing I would say is if inflammation is the problem in many of these afflictions, there are new therapies like hyperbaric oxygen, which is supposed to be good for the brain, red light, a process called Bimini that oxygenates a bathtub and then it goes in through transdermal. Um, there's something called NanoV. So each of these are anti-inflammatory, and all of them seem to help. So there are a variety of other therapies one can look at too that are preventative but also restorative.
So, Solomon,
Yes.
Lee Steinberg is the expert, but I humbly disagree with the statement that he just made, just to show there isn't unanimity in this field.
Yeah.
The idea of hyperoxygenation, I tried that in some patients many years ago when I was head of neurology and neuroscience at Duke. We had one of the first chambers, and it didn't seem to work, but it wasn't a concerted study. Then I
Okay.
came here to Houston, and there was a hyperbaric chamber that was asking me to send over all our ALS patients. And I said, I'm happy to do it as a trial, but you cannot charge the patient because we want to find out if it works. And the
Yes.
problem is the particular owner said, sorry, Dr. Appel, we're not going to give you anything for free. So
Wow.
we never did that study. But I will tell you, with all due respect to Lee, hyperbaric oxygen or any of these approaches haven't worked. I wish the hell they would work because they would be so important if they would. It's very similar. I get calls all the time about Lyme disease causing ALS in our patients. I wish it were Lyme disease because we know how to treat that and we can cure that. But unfortunately, it isn't the case.
Dr. Appel,
Yeah,
the next question comes in. It asks, are there biomarkers or blood tests or imaging tools or other technologies being developed to identify early signs of brain injury or neurodegeneration? To that, you say what?
Absolutely, yes. I think as we were talking about before, one of the amazing things is neuroinflammation, whether it's coming from the brain in Alzheimer's disease, whether it's paramount in the blood in ALS. There are effective biomarkers telling us, hey, there are bad guys spitting out cytokines that are toxic in the blood. These can be measured. Now, the key issue is, are they specific for ALS or specific for Alzheimer's? And they are not. So that's the problem. You can't just go measuring these and assuming that you can take the place of going to a doctor and having it properly diagnosed. All you can say is there's inflammation, and you may have 100 different causes giving rise to that same biomarker.
So Solomon, let me just try to tie something together here
Mhm.
between uh, Dr. Appel and Lee Steinberg. The bottom line to all of these potential therapies is that we don't know unless we study them in a
Yeah.
controlled manner. That's why we're studying this combination. I get letters all the time from people who have ALS or FTD. Can I have this therapy now? And my answer is, first of all, no, because we're studying it. First, we have to show that it has that it's effective. Right now, we
Yeah.
know it's potentially effective. So whether it's hyperbaric chambers and all the rest, we need to look at all of them, but they have to be studied under controlled conditions before we can determine whether they're actually effective or not, despite having a case here or a case there that may or might not have responded.
Well, Lee, I know you are an expert on this next question because it asks, is this mainly a football problem, or should parents of soccer, hockey, and other athletes be just as concerned?
All athletes that have the potential for impact into the head and the brain have this risk.
Mhm.
And again, they did tests on young girls playing soccer, and they had a high rate of concussive events because their neck was thinner and
Mhm.
it had less bulk to sort of hold the head up. So you have to look at soccer, you have to look at field hockey, you have to
Mhm.
look at obviously football, but they happen everywhere, and so it's all about protecting the brain for the same reason that people insist on having a helmet for kids who ride bicycles. Um, I don't know why there's not a helmet for soccer.
Great
And
point.
it strikes me that they need that protection too, because look, we define a collision sport as something where the primary um, action in the game is the collision of two bodies.
Yeah.
But having said that, in soccer, you have people running at very high rates of speed. They're not aware, they're not prepared for the hit. In a number of other sports, you have the same thing. In baseball, you can have a concussion by bumping into the outfield or getting tagged at home base. You can have them. Basketball is the biggest contact sport that's considered a non-contact sport
That's right.
if you just look under the thing. So this is true for everything. And the role of parents is paramount, because to the extent that you're having your children play dangerous sports at a young brain, that brain is still in development. At 9 years old, that brain may be developing into the 20s. So you have to protect it, because we all need to have executive function and decision making and processing, and this is what is threatened here. So I'm all for parents being interventionists.
Yeah, this parent is asking a question, Lee, that their kids do play a contact sport, but have never been diagnosed with a concussion. Then they ask, how worried should they be? And I'm sure you're probably going to tell us a little bit about subconcussive blows, right?
Right. So the point is that look at the sport. Um, I mean, everyone talks about quarterbacks and concussion in football, but it's actually the offensive and defensive linemen that hit on every single play. You have subconcussive events, as Dr. Appel mentioned. There are biomarkers and tests that can be
Mhm.
done. I mean, they used to have baseline testing,
Yeah.
which is pretty widely done now. And someone would take a cognitive test and preseason, and then after they got hit, they'd take another one. Matter of fact,
Yeah.
Peyton Manning used to dummy up on his test so it wouldn't look like he was impaired from concussion. But um, but there are IQ tests, there are blood tests, there are a variety of ways, and obviously there's the symptoms, which are, headache, loss of balance, sensitivity to light, and noise. There are a variety of different markers. So, again, I would urge people to be proactive if they're raising children, because the child is not going to naturally protect themselves. And the coach may or may not have that interest in mind, which is long-term health. So this is one issue, brain health, where it serves you well to be a proactive parent.
Well, this question is for all three of you as we conclude the program. And Leah, and I'll let you take it first. Again, where could public attention or funding make the biggest difference over the next few years?
Research like what Dr. Grossman is doing.
Yeah.
It can studies that show us exactly what the effects of certain new medicines or protocols can be. In other words, if the brain was the last frontier of medical research back in the 1980s, and it's progressed, but it still has ways to go to
Mhm.
understand more about brain function. So funding is helpful in all those ways.
Dr. Appel, how would you answer that question in terms of public
I
attention
can't
and
say it
funding?
more clearly than Lee just said it. Total agreement. I
Hmm.
think if we could study this with resources that would allow us to do double-blind, placebo-controlled, as Fred was talking about, as well to define the biomarkers and their sensitivity and selectivity with respect to certain diseases, all of these would be dramatically important and make game-changing possible. And the earlier we get patients into such studies, and the earlier we try novel therapies such as Koya is doing, the better we're all going to be. And I must just add to the strength of Lee's statement with regard in Houston, the women's soccer is probably the number one problem we have with regard to concussions, amazingly. And that's truly supportive of his comment.
Dr. Fred Grossman, I'll give you the final word. In what way could, you can make maybe the biggest public statement in terms of the funding that's needed to help push this initiative forward?
I think it's critical to have strong links between academia,
Yeah.
government, and private companies. It's critical that those three groups work very closely and prioritize brain health. And I would also say the inclusion of the latest technology, including AI, into what we do, because this is a race, and we have to really get to this finish line quickly. And it's affecting all parts of society. And today we're focusing on sports which I think is great because it is an area where research can be done. It's an area of tremendous need, and I think we need to be very serious about that as well.
Well, we want to thank everyone for joining us on Beyond the Hit, how repetitive hit, trauma, inflammation, and neurodegenerative disease all intersect. We want to thank Lee Steinberg, Dr. Stanley Appill, and Fred Grossman of Koya Therapeutics. Thank you for joining us, everyone. I'm Solomon Wilcots. We'll see you next time.